welcome to the deep dive. Today we're looking at something pretty relevant for a lot of industries, which is, well, what do you do with this absolute flood of data we have now?
Right, it's everywhere.
Exactly. And specifically, we're going to dive into smart factories and this interesting idea called the DXAI IoT Prism. Think of it as maybe a shortcut, a way to get a handle on all that information pouring out of connected machines, turning raw data into something clear, something you can actually act on.
Yeah, that's a good way to put it. We've been looking at the documentation, the blueprint for the system, and it really is designed to take that complex stream of data you get from sensors, devices, all that stuff in a modern factory.
Right.
And just make sense of it, process it, analyze it, and then importantly, show it to you in a way that's, well, easy to grasp.
Okay, so maybe for someone listening who doesn't deal with machine data all day, why should they care about this Prism? What's the real takeaway for them?
Well, the core advantage, especially for you listening, is that it lets you understand really complex IoT data without needing like a PhD in data science.
Okay.
It's about getting the important stuff, the information you need to make smart decisions, presented clearly. So instead of being buried in number.
Yeah, that feeling of being overwhelmed.
Exactly. Instead of that, you get insights you can actually use. I mean, imagine being able to see a machine failure coming before it actually stops the line. That's the kind of potential we're talking about here.
So it's almost like having a super smart data analyst kind of built right in, even if you don't have that expertise yourself.
Precisely. It gives you a whole suite of tools, helps you make better decisions based on actual data, lets you keep an eye on things in real time, and even anticipate potential problems. Think of it as shifting from just reacting when things break
To actually getting ahead of them, proactive.
Yeah,
Exactly.
proactively preventing them.
Now, this is where, for me, it gets really interesting. How does it actually give those insights to someone who isn't maybe a tech wizard? What's the magic there?
The magic, yeah. It really comes down to AI, artificial intelligence. The system uses it in a few key ways. First, it automatically scans the data for patterns, anomalies, anything unusual.
Okay.
Second, it kind of guides you, helps you focus on the most useful ways to actually look at that data. And maybe the most exciting part is you can actually ask it questions in plain English.
Really, plain English.
Yeah, and it gives you answers you can understand.
So, could I literally ask it something like, hey, was the cooling system in Building B acting up last week?
Exactly like that. And the system should be smart enough to understand what you mean, grab the right temperature data, look at how it changed over that week, and then show you, maybe with a simple chart, if there were any weird spikes or drops, maybe highlighting the problem areas.
Wow, okay. That sounds incredibly practical. So what's the basic structure? How does this Prism thing actually take all that raw info and turn it into those, easy to understand answers? What's the data's journey?
Think of it like a pipeline, maybe. First, step one, it collects data, pulls it in from all the connected devices, the sensors, everything in the factory.
Right.
Then that data goes through processing. It gets cleaned up, organized, put into a standard format.
Okay, tidying it up.
Yeah. Next, it's stored securely. But the real core, the engine, is the analysis stage. That's where the AI and specialized tools get to work, digging through the data for those insights.
That's the magic part again?
Sort of, yeah. And finally, it hits the visualization stage. This is where those insights get presented back to you in a clear, user-friendly way. Charts, dashboards, you name it.
Okay, that gives us a good picture. Now let's maybe dive a bit deeper. What makes this Prism system really tick? What are the fundamental ideas, the core values it's built on?
Sure. The documentation we looked at really emphasizes 5 core values. The first one is intelligent interaction.
Okay.
This is all about making it easy for anyone, really, to explore the data. Using those natural language questions we just talked about is a big part of it.
Like the cooling system example.
Exactly. And the system also gives you suggestions, like based on the data you're looking at, it might recommend certain types of analysis that could be useful. So you don't even necessarily need to know what to ask. It can guide you.
So it helps you figure out the right questions.
In a way, yes. You could ask, like, show me the temperature change trend for facility X last week, or maybe something broader, like, what's the most common alarm type we're seeing across the board?
That really lowers the barrier, doesn't it?
Yeah,
You don't need to be a data guru to start getting value.
absolutely. That's the goal. The second core value is in-depth analysis support. So it's not just showing you pretty charts of surface-level stuff.
Right.
The Prism has various built-in analysis tools that go deeper. We're talking things like time series analysis, tracking how data changes over time. Or distribution verification, basically understanding the typical range of values for something, like a pressure sensor, histograms, box plots, that kind of thing.
Seeing what's normal.
Exactly. And also correlation analysis, seeing how different readings might be connected, are temperature and vibration related for this machine, that sort of thing. Heat maps, scatter plots help with that. And importantly, anomaly detection, automatically flagging those weird readings that might signal a problem.
So it's not just presenting data. It's actually giving you the tools to investigate, to really dig into what's happening under the surface.
You got it. Which leads nicely into the third core value, efficient decision-making support. The whole point here is that by showing you the results of these detailed analyses clearly and concisely, you can make smarter decisions faster.
Right.
It helps you move away from just relying on gut feelings or experience alone towards making choices backed by solid data.
Crucial for staying competitive, staying efficient. What else guides this?
Okay, number 4 is data integration and accessibility. This platform is designed to be a central hub. It brings together all those different streams of IoT data.
From all over the factory.
Yeah, from potentially lots of different systems into one place that's easy to navigate. So no more hunting through 5 different dashboards or struggling with data stuck in silos that don't talk to each other. Imagine having like one single control panel for your factory's vital signs.
A single source of truth for all that critical manufacturing data. That sounds like it could save a massive amount of time and probably cut down on errors too.
It really can. And the final core value, number 5, is intuitive visualization. We touched on this, but the system uses simple, easy-to-understand formats, charts, graphs, dashboards. Plus, there's a consistent look and feel, this Prism theme, which helps your eyes quickly spot the important stuff, patterns, trends, and those critical anomalies.
Ah.
It's really designed for visual clarity, to help you instantly understand what the data is trying to tell you.
So it's powerful under the hood, but also designed to be user-friendly, visually consistent. Makes it easier for anyone to interpret. Okay, good. Now let's shift gears a bit. What can this system actually do in practice? And maybe where could it go in the future?
Right. The documentation really hammers home how this system enables the strategic utilization of IoT data. It's about moving beyond just, seeing what happened yesterday.
Very active.
To actually using that information to drive your overall business strategy. This feeds directly into business innovation and decision support. By analyzing this data intelligently, you can find concrete ways to improve operations, cut costs, maybe even spot opportunities for new products or services, and ultimately keep customers happier.
So connecting the dots between those sensor readings and the bigger business picture.
Precisely. They even lay out this concept called a value pyramid of functional architecture. It's quite neat, actually.
Okay, a pyramid. How does that work?
So at the base, the foundation, you have data integration. That's getting all the data in, collecting it, standardizing it, handling real-time streams, ensuring quality, managing metadata, all that groundwork.
Makes sense. The foundation.
Then the next level up is data visualization. That's your charts, graphs, dashboards, making the data visible and understandable, often interactive. Building on that, you get to intelligent analysis. This is where the AI and machine learning really shine, identifying patterns, detecting anomalies, running predictive analyses, optimizing processes, and that natural language Q&A feature we talked about.
Okay, the smarts layer.
Exactly. And right at the very top of the pyramid is strategic value creation. This is where all those insights actually translate into tangible business improvements, better efficiency, new ideas, fostering a more data-driven culture overall.
That pyramid structure really helps visualize how the value builds up. Okay, so what are some specific ways a system like this can really unlock the potential sitting in all that IoT data? What are the concrete benefits?
Well, several key areas pop out. First, as we've kind of mentioned, improved data integration and accessibility. Just breaking down those silos is huge.
Getting everything in one place.
Right. Second, increased operational efficiency. That real-time monitoring allows for things like proactive maintenance, which directly leads to less unplanned downtime. Imagine knowing a critical pump needs servicing before it fails and stops production. That's a massive win.
Yeah, downtime is killer.
Definitely. Third, there's the potential for new business value creation. By analyzing how equipment or products are actually being used in the real world, you might spot opportunities to refine them, improve them, or even offer new services around them, enhance the customer experience.
And the AI features obviously play a big part here too, right?
Oh, absolutely. The Gen AI-based analysis and Q&A are significant advantages. Just being able to ask questions in plain English makes the data so much more approachable for, well, everyone.
Takes the intimidation factor away.
Exactly. Plus, the system can perform automatic insight generation. It might spot subtle trends or correlations that a human analyst, even a skilled one, might just miss sorting through mountains of data.
Things hidden in the noise.
Precisely. And the fact that it can help generate analysis reports, that saves users a ton of time and effort. Instead of manually compiling reports, the system can automate much of that.
So it's like having this tireless AI-powered analyst assistant working for you 24/7.
That's a great way to think about it. And it's not just reactive. The system also offers intelligent analytics recommendations. Based on the kind of data you're looking at, is it time series data? Is it categorical failure codes? It can suggest the most appropriate analysis methods and visualizations.
Ah, so it guides you towards the right tools.
Yes, and it can even learn. Based on your past queries or the analysis you've done, it might suggest follow-up analyses that could be relevant or insightful. Understanding user intent, they call it.
So it's not just passively waiting for instructions, it's actively trying to help you find discoveries.
Okay, looking ahead then, how might a system like this evolve? What's next? What's on the horizon?
The documentation points towards some really exciting possibilities. One big one is advanced predictive analytics. Combining Gen AI with more traditional machine learning could lead to much more sophisticated and accurate predictions.
Like what kinds of predictions?
Things like predicting the remaining useful life of a specific component or forecasting product quality issues with higher accuracy. And importantly, being able to explain why it's making that prediction in natural language.
Okay, so not just a black box prediction, but an explanation too. That's key for trust.
Absolutely. Another really interesting area is autonomous operations and control. The idea that the system could eventually analyze data in real time and then automatically adjust equipment settings, maybe optimize performance, or even take action to prevent an imminent failure.
Wow, closing the loop. The system actually takes action. Potentially, yes. Further down the line, we might also see more personalized analytics experiences. So dashboards and recommendations that are specifically tailored to an individual user's role and responsibilities.
Makes sense. A plant manager needs different info than a maintenance tech.
Exactly. And finally, the potential for integration of external data. Imagine combining your internal factory IoT data with, say, external weather forecasts or raw material market prices or supply chain information. That could unlock much broader, richer insights.
The potential really does seem huge. Okay, let's get a bit more granular now. Can we talk about some of the specific tools and techniques inside this DXAI IoT Prism? Particularly how it helps visualize and analyze the data.
Sure. The documentation details several key analysis modules. First up, there's time series analysis. Think of this as your go-to for looking at data points collected over time, like those temperature readings from a machine taken every minute we talked about.
Right.
This module helps you spot trends. Is the temperature generally creeping up? It helps detect sudden changes, spikes, or drops. And it can identify recurring patterns or cycles in the data. Maybe a machine runs hotter during certain shifts.
So if you wanted to see if a machine's performance is slowly degrading over months or if it has a regular daily peak, this is the tool. Got it.
Correct. Then you have distribution analysis. This is all about understanding the spread of your data. Like, what's the typical operating range for that sensor? It uses things like histograms and box plots to show you if the data clusters tightly around an average value or if it's more spread out or maybe skewed. This is really crucial for establishing that baseline of what normal looks like. And that, in turn, helps you spot outliers, those unusual values that might indicate something's wrong.
Understanding normal is key to spotting abnormal. Makes sense.
Absolutely. Next, the pattern analysis module. This helps you explore potential relationships between different data points. For instance, is there a correlation between motor speed and vibration levels?
Ah, cause and effect. Or at least correlation.
Exactly. It uses visual tools like heat maps and scatter plots to help you see these connections and identify underlying patterns that might not be obvious otherwise. You might discover that when sensor A goes up, sensor B consistently goes down.
Revealing those hidden interactions. Okay.
Then we move into some more advanced stuff with the Advanced Analytics module. This includes techniques like frequency analysis, often called FFT, which is great for analyzing vibrations in machinery to diagnose wear and tear.
Like listening to the machine's heartbeat almost?
In a way, yeah. It also includes time frequency analysis, looking at how frequency characteristics change over time. Useful for understanding short-lived events, plus more sophisticated anomaly detection methods that go beyond simple thresholds, and even tools for analyzing the patterns of equipment startup and shutdown cycles to look for irregularities.
This sounds like the toolkit for really getting deep into the health and performance diagnostics of the equipment.
Precisely. And there are specialized visualization tools too. For example, 3D visualization. Sometimes plotting data with 3 variables in a 3D space can reveal complex relationships or clusters that are just hidden in a flat 2D chart.
Right, adding that extra dimension.
Yeah, it can offer valuable new perspectives. There are also tools focused on alarm analysis, specifically designed to help you compare your current alarm threshold settings against the actual historical data to see if they're set effectively or if they need adjustment.
Fine-tuning those alarms. Crucial.
And weaving through all of this is the IoT data analysis curation aspect. This is where the AI really acts as your guide.
Okay.
It can recommend the best visualization types or analysis methods for the specific data you're looking at. It can provide explanations of the insights it finds in plain language. And it enables that Q&A feature, letting you ask questions as you explore.
So the AI is like a knowledgeable co-pilot, helping you navigate the data and pick the right tools for the job.
Exactly. And this leads to things like automated recommended analysis, where the system might proactively generate some initial insights or suggested analysis paths based on the data. You often see an analysis flowchart too, which visually maps out the steps of a particular analysis sequence.
So transparent.
Yeah. And the AI analysis recommendations come with explanations, justifying why it's suggesting something. And again, you can always ask follow-up questions.
It really sounds like a comprehensive and, importantly, user-friendly way to tackle what can be incredibly complex data. Okay, let's make this even more concrete. Can you give some specific examples of how these different visualization and analysis tools might actually be used on the factory floor?
Sure. The documentation provides plenty of practical applications. For time series data analysis, you could track, say, the output pressure of a critical pump over the last month. You'd easily spot if it starts fluctuating wildly, indicating a potential problem, or see if there's a regular daily pattern in its energy use that you could maybe optimize.
Okay, straightforward.
Using histogram analysis, you could look at the operating temperature data for a furnace over the past year. The histogram would clearly show you the typical range, the normal operating zone. Based on that, you could set much more effective high and low temperature alarms.
Right, setting those thresholds based on actual data, not just guesswork. That's key for avoiding both missed issues and annoying false alarms.
Absolutely critical. Then, box plot analysis. This is great for comparisons. You could use it to compare the overall equipment effectiveness, the OEE, of 3 different production lines side by side for the last quarter.
See which line is performing best.
Exactly. Or you could use it to analyze if machine performance dips significantly during summer months due to heat, maybe? Or identify if specific product types running on a line correlate with unusually high defect rates.
Okay, so good for comparing groups or conditions. What about heat maps?
Heat map analysis is excellent for visualizing patterns related to time. For example, you could create a heat map showing machine downtime occurrences across the hours of the day and days of the week. You might clearly see a hotspot. Maybe failures are much more common late on a Friday afternoon.
Interesting. They could definitely inform maintenance schedules or operator attention.
Precisely. You can really see how each visualization method gives you a different angle, a different lens to understand the same underlying data.
Yeah, definitely. Keep going.
Okay, daily, hourly pattern analysis. This helps understand recurring cycles. You could analyze the typical energy consumption pattern of the whole plant throughout a 24-hour period. This helps predict peak load times, optimize energy purchasing, or maybe adjust production schedules to smooth out demand.
Smart energy management.
Exactly. Anomaly detection, we've mentioned it a few times, but it's crucial. Early identification of equipment behaving strangely allows for that proactive maintenance, preventing catastrophic failures and costly, unplanned shutdowns. Catching subtle deviations early saves big money later.
Those early warnings are invaluable.
Indeed. Moving to the more advanced stuff. Frequency analysis, FFT. You could analyze the vibration signature from a large motor, Specific frequencies might indicate bearing wear long before it becomes audible or causes major issues. It helps filter out background noise too, focusing on the critical signals.
Like finding the needle in the haystack of vibrations.
Pretty much. And time frequency analysis lets you see how those frequency signatures change over time. Useful for analyzing, say, the startup sequence of a complex machine. Does it hit the right frequencies at the right times? Or identifying transient, short-lived abnormal events based on their unique spectral fingerprint.
Okay, this is getting into some really sophisticated diagnostic territory.
It is. Trend analysis, similar to time series but often focused on longer-term, slower changes. Is the overall efficiency of a chemical process gradually declining over months? You can use trends to predict future performance or detect that slow degradation of components needing eventual replacement.
Seeing the slow burn issues.
Right. Correlation analysis, again, helps pinpoint key influencing factors. What sensor readings have the strongest link to product quality variation? Identifying these core variables is essential for any optimization effort. Quantifying those cause and effect, or at least correlation-based relationships.
Finding the levers you can actually pull to make improvements.
Exactly. Comparative group analysis. This is great for A/B testing or verifying improvements. Did the changes we made to line B actually improve its throughput compared to line A? Or comparing performance under different operating conditions? Analyzing the key differences in sensor readings between normal operation and periods right before a failure.
Being able to objectively measure the impact of changes is huge. No more arguments about whether something worked.
Absolutely. Data-driven proof. 3D visualization analysis, as we mentioned, helps grasp complex multivariable relationships. Maybe plotting temperature, pressure, and flow rate together reveals a hidden cluster of operating points that lead to problems, something you'd miss looking at 2D plots separately.
Seeing the bigger picture, literally.
Yeah. Pattern clustering analysis can automatically group similar operational patterns. For example, it could automatically identify distinct modes of machine operation based on sensor data, perhaps corresponding to different products being made, or even automatically separating normal daily patterns from abnormal ones.
Automating that classification of complex behaviors could uncover insights you wouldn't even know to look for.
Precisely. And finally, the tools for alarm and threshold setting. Beyond just setting them, the system can help recommend optimal thresholds based on historical data analysis, compare the effectiveness of different alarm strategies, maybe fewer alarms, but smarter ones, improving the overall reliability and trustworthiness of your alert system. And operation shutdown cycle analysis helps visualize and benchmark those normal startup shutdown sequences, making it easy to spot deviations that might indicate a developing issue.
Wow. Okay, that's a really comprehensive suite of tools. It's clear this kind of system offers a powerful way to make sense of the sheer volume of data in modern manufacturing. So, looking ahead again, as tech keeps evolving, what are some of the key future directions or potential enhancements for something like DX AI IoT Prism?
Right. The documentation does outline several key areas for future development. One, pretty fundamental, is building out a robust, large-scale IoT data processing architecture. As the number of sensors and data volume continues to explode, the underlying platform needs to scale efficiently to handle it all.
Makes sense. Need the horsepower.
Definitely. Another critical area is enhancing the real-time monitoring and alert system. The goal is to move beyond simple, if value exceeds X, send alert type rules.
Which can generate a lot of noise, right? False alarms.
Exactly. Moving towards more intelligent anomaly detection algorithms that understand context, look at multiple variables together, and are much better at identifying truly critical events while significantly reducing those false positives.
Yeah.
This involves things like real-time stream processing and probably more flexible multi-channel alerting, SMS, email, maybe even integrated messaging apps.
Smarter, more reliable alerts that you actually pay attention to. That would be a huge improvement for operators.
For sure. There's also a big focus on integrating embedded machine learning models directly within the Prism system itself.
What does that mean exactly?
Well, it essentially means creating a user-friendly environment, sometimes called MLOps, machine learning operations, where users, maybe process engineers or data analysts, could actually train, manage, and deploy their own custom machine learning models for specific predictive tasks right there inside the platform.
Oh, okay.
Think of an intuitive interface for training models, dashboards to evaluate how well they're performing, and automated pipelines to deploy them, maybe leveraging popular open-source libraries like scikit-learn or TensorFlow.
So bringing that power of custom machine learning directly to the users within the platform they already use. That sounds like a potential game changer for advanced tailored analysis.
It really could be. The document also talks about expanding the advanced analytics capabilities further, incorporating more pre-built, domain-specific analysis modules, things like automated root cause analysis tools, specialized predictive maintenance models for common equipment types, or process optimization algorithms. They're even considering an extensible plugin architecture.
A plug-in architecture.
Yeah, basically allowing users or third parties to develop and integrate their own custom analysis scripts or specialized models into the Prism environment.
Wow, that kind of flexibility would make the system incredibly adaptable to all sorts of niche manufacturing processes and needs.
Absolutely. And finally, there are plans to further enhance the automated data analysis and report generation, using generative AI, like the technology behind ChatGPT, to automatically generate initial exploratory data analysis summaries as soon as new data is loaded.
Like a first-pass report, automatically.
Kind of, yeah. Summarizing key features, distributions, potential outliers, and also implementing more sophisticated automated reporting where customized analysis reports can be automatically generated and distributed based on predefined schedules or specific trigger conditions.
Automating more of that routine data crunching and reporting would free up so much valuable human time, wouldn't it? Letting people focus on the interpretation, the strategy, the decisions.
Precisely. At the end of the day, it's all about making that journey from raw, messy IoT data to clear, actionable business intelligence as smooth, as efficient, and as accessible as possible for everyone involved.
Well, this has been genuinely fascinating, a really insightful deep dive into this DXAI IoT Prism concept. It absolutely sounds like a powerful and pretty versatile approach for transforming how manufacturers can actually use the massive amounts of data they're generating.
Yeah, the potential is definitely there.
So just to quickly recap for everyone listening, we've explored how this integrated AI framework, the Prism, is designed to effectively process, analyze, and visualize that complex manufacturing IoT data. The key is making it accessible, making it understandable, not just for data scientists, but for a much wider range of people in the organization.
Right, regardless of their technical background.
Exactly.
Yeah.
We looked at its core values, that intelligent interaction, the in-depth analysis, efficient decision support, data integration, and intuitive visualization. We covered the key features, the AI capabilities like natural language Q&A, and the exciting future possibilities, especially around things like more advanced predictive maintenance and maybe even heading towards autonomous operations down the line.
And it's worth just quickly restating those core values because they really guide the whole thing. Intelligent interaction, in-depth analysis, efficient decision-making, integrated data access, and clear visualization. These are the pillars aiming to empower users, unlock that hidden value in the data, and drive real improvements.
Definitely. So here's maybe a final thought to leave you with, our listener. Thinking beyond manufacturing for a moment, how could a system like this one that makes complex data accessible and analyzable through AI and natural language, how could that fundamentally change your approach to understanding information and making decisions in whatever data-rich environment you might work in?
Interesting question.
Yeah, what kind of unexpected insights, what sort of aha moments could be unlocked if analyzing complex data became this much easier, this much more intuitive, something to think about? We encourage you to consider the possibilities in your own fields. Thanks for joining us for this deep dive.